This is Ali Pinjani, and we're going to go over Physics 2212 Lab 1. The introduction. The purpose of the lab is to use tape in order to observe the interaction between two electrically charged pieces of tape. The fundamentals. Use tape model point charges by assuming each piece of tape has equal distributed charge in order to apply Coulomb's law. We use three concepts: Newton's second law, F equals ma, gravitational force, and Coulomb's law, which is a look. The picture is located at the bottom right of the screen to calculate the change on each shape. Also use the approximate dimensions of an atom to calculate the number of extra or less atoms that are added to the piece of tape. There's Here's a little summary of the results. The charged piece of tape are repulsed from each other, and the charge was seen to be a positive one. Charge of each tape is 6.98 e to the negative 9 coulombs, and the number of electrons lost are 4.36 e to the 10 electrons. The model. Each piece of charged tape was used to model a point charge to observe interactions between them on a larger scale. Assumptions. We are treating the long piece of tape as a point charge concentrated at the center of the large tape. Assume that each U tape had the same amount of charge evenly distributed along the piece of tape. Experiment. We have a system. Tape A, which is the U tape, and tape B, which is the base tape. Everything else can be considered the surroundings of the system. Initial conditions. Two pieces of tape that are neutral, that are about equal in length. The other piece is stuck down to the desk that is also neutral. The context of the experiment. Tape A was stuck down to tape B and ripped off quickly from it to get a charge, which will either leave behind electrons or allow it to gain them. The tape is tested on other objects to see if they will attract or repel. The tape A is hung on another surface to see if another tape A will float and the measured distance is observed. Observations. Tape A was attracted to my hand but repelled by another piece of tape A. It was also attracted to other objects like a neutral book or a negatively charged pen. This will only lead me to believe that the tape was positively charged and its electrons are lost when tape A is ripped or during the charging process. The data and calculations of the experiment. The mass is 0.0043 grams. The length is 14.5 inches. Width is 0.75 inches. Distance is zero point 0.4 inches. The force of gravity is 0.0042183 newtons. The charge, as said earlier, is 6.98 e to the negative 9 coulombs. The number of electrons lost are 4.36 e to the 10, and the ratio is 6.31 e to the 6 electrons/electrons lost. Here's the glow script to model the force type. The red ball is the U tape or tape A, and tape B is the blue ball. The force of gravity is shown with the red arrow, not the red arrow, the orange arrow, and the green arrow is the force of the electron. As you can see, they're balanced out. Assumptions and errors. Assume air resistance and of friction are negligible. Assume that the long tape is a point charge. Assume each piece of tape had the same amount of evenly distributed charge, unequal distribution of charges on each tape, and a loss of charge due to handling or the environment, like the tape getting stuck to our hand and losing its charge. Discussion. What if electrons and protons had inverse charges? All of the observations throughout the lab would remain the same, although the charged pieces of tape would now be negative. They would still repel each other and attract to a now positively charged pen. Why is it so important to handle the tape as little as possible? The tape begins to neutralize when it comes in contact with the hand or other objects as then they try to gain back the electrons they lost. This is the physics lab. Thank you for having me.